Hi guys, today I'm just gonna talk about what I learned today. Today the main topic is why do we need such a computer architecture? Architecture. So why do we need some kind of computer architecture, and also why we have to learn the computer architecture, and why we have to learn about computer architecture. Example, you are a web developer, web engineer, front-end web engineer, and actually you don't have kind of like opportunity to look at the computer architecture. So example, Linux operating system, they use x86, and I think the Mac OS, they use ARM. And but the question is, why do we have to learn about some kind of computer architecture? I think the key of computer architecture is the most important part is that your app, whatever, your app, web, whatever, is running on operating system. So operating system is just the doing everything, like example memory management or like context switching or whatever. So the operating system, so it's gonna be really important key of the software nowadays. But the operating system is kind of it's just the abstract software based on the computer architecture. So if you're trying to build the operating system, you finally realize that you cannot build operating system without not knowing computer architecture. You have to know about some kind of target computer architecture, and based on that, you can make some kind of operating system. So that is how it does. Um, so if you're trying to learn about some computer architectures like assembly language, those kind of things, you are able to learn about why we have some kind of Docker or some kind of virtual machine on it. Example, Docker is the containers. It's just the operating system virtualizations. But why do we need Docker? Um, the operating system container, the operating system virtualization is really important because our environment is different. My environment is gonna be okay, but your environment is gonna be not compatible with my environment. To handle this, we virtualize this kind of operating system into some kind of library which is called container. And but why we need some kind of those kind of thing? That's because if you trying to if you look at how does it operating system, just the abstraction level of the computer architecture, example, ARM, your Mac OS, you have Linux, have different computer architecture. The x86 had different architecture. Of course, if you look at the register of it, and it compiles differently. Example, the opcode. Opcode is just the kind of actions in assembly. Example, move, push, pop, whatever is kind of like this kind is called is opcode. And those kind of thing is basically already basically made of thing. What they made of? I mean, like it's already there's the byte code, the corresponding to this kind of action. And the x86 and x86 A6 and the whatever ARM, they have different ISA instruction set architecture. I think instruction set architecture. I think those are the things. So basically the some instructions in x86 is not supported in the ARM. So, but what happens if the some kind of code, if your software rely on some kind of instruction that heavily relies on the x86 but not ARM? So that's gonna be that's gonna be like issue on it. So to solve the issue, we just trying to abstract into operating system, but still the operating system cannot be same because the binary input, the bin input, the binary input based on the x86 like Linux and the Mac OS is really different. I think it was like the FAT ELF or the whatever those kind of is the output file is different. So to even handle those kind of issues, we make virtualized thing based on the operating system, which is called Docker container. So Docker is just a type of container. So that is it. So that is why we have to understand computer architecture to understand operating system. The era, the I mean like the software engineering, the history is just a bunch of abstraction. We face issue and we somehow that is find out that is repetitive and we just make it abstraction level to simplify it. Even the data structure is the same. Example, we have the DB indexing. We just put all of the record keys on some kind of array or linear. If you put it, we have to traverse it until it counters the target value. Rather than make it linear, we're trying to make it the more better way, which is the tree data structure. So binary tree. The limitation is it can have one children. So if there's the only one children and if there's more tree height on it, there's more big time complexity. To solve an issue, there's B-tree, the B-tree, those kind of data structures come from. So everything is kind of abstraction level. We face problem and we somehow solve it. And if it is repetitive and we think that is nice, that is really innovative, and we just make it into, we just simplify it. We just adapt into new technology, and that's the era and history of the computer science and the software engineering, and that is happening nowadays. So this is it. Have a nice day. See you next time. Bye bye.